Let's talk about one of the biggest headaches in construction, quantity takeoff. You know the drill. For way too long, it's been this chaotic, manual process of measuring, exporting data, and then doing it all over again when something changes. But what if you could flip that script? What if you could turn all that chaos into a controlled, automated, and genuinely intelligent workflow? Well, that's exactly what we're going to dive into today.
Just stop and think about that question for a second. What if your spreadsheet, your bill of quantities, just knew? What if it updated itself every time the design changed, without you having to hunt down every little revision? Imagine a world where a design update doesn't send you right back to square one. That's not some far-off dream. It's the whole point of a 5D-ready workflow, and we're going to break down exactly how it works. So, here's our game plan. First, we'll dig into the problem itself, the absolute chaos of constant change. Then, we're going to see how to build a live bridge between your 3D model and Excel. After that, we'll get into the really cool part, mastering design revisions. From there, we'll unlock all the hidden data inside your model, and finally, we'll tie it all together to fully automate your final quantities.
Okay, let's kick things off with Section 1, the chaos of constant change. See, here's the fundamental problem. Construction projects are basically living, breathing things. They're always evolving. But the tools we've been using to measure them, they're completely static. And that creates this massive disconnect that leads to mistakes, huge risks, and just so much wasted time.
This really just nails the difference, doesn't it? The old way is static. It's a snapshot in time that's out of date almost immediately. It's completely manual, which means endless, tedious data entry. And because of all that, it is incredibly risky. The 5D ready way, on the other hand, is dynamic. It's alive. It's automated, so you're using logic instead of just clicking around. And the result? It is just fundamentally more accurate. So how do we make that leap? That brings us to Section 2, and the very foundation of this whole thing, connecting your model directly to Excel. This isn't just a small step, it's a total paradigm shift. We're talking about throwing away the paper map and turning on a live GPS for your project. And at the heart of this is what we call a 5D ready workflow. So what does that actually mean? Well, it's a process where your 3D model, your quantities, that's the 4D part, and your costs, the 5D, are all dynamically linked together. They're not separate documents living in different folders. Nope, they're all part of one single interconnected system. When one thing changes, everything else just reacts automatically. You know, I love this analogy because it's just perfect. Your old QTO spreadsheet is a paper map. Sure, it was accurate the moment you printed it, but the second the road network, or in our case, the building design changes, it's totally useless. A live linked model is your GPS. It knows where you are, it sees the changes ahead, and it recalculates the route or the cost in real time. Which brings us to what is, for my money, the single biggest payoff. Section 3, mastering design revisions. This is all about one simple, beautiful promise. You will never have to start your quantity takeoff from scratch ever again. And you know, the real power here is just how simple and intuitive it is. When a new model revision lands on your desk, the software automatically compares it to the last one and color codes everything that's different. Green means new, orange means something's been modified, and red means it's been deleted. All of a sudden, you're not hunting for changes anymore. The changes are jumping out at you. Just think about how that plays out. The architect extends a wall by 500 millimeters, adds a new partition over here, and takes out a window over there. In the old world, that's 3 separate things you have to manually find, check, and adjust. In this workflow, the system instantly flags the changed wall in orange, the new partition in green, and the removed window in red, and it updates the quantities for all 3 on the spot. Okay, so once you've got revisions handled, what's next? Well, we move into Section 4. This is about unlocking your model's data. Because, trust me, these BIM models know a whole lot more than you probably think they do. They're packed with valuable information, not just geometry. Now, to wrangle all that data, we use something called QTO views. Think of your entire BIM model like a massive library. Trying to measure everything at once is impossible. A QTO view is like checking out just one specific book. It's a custom, filtered snapshot that lets you isolate exactly what you need to measure, like, say, only the structural columns on level 2, and it cuts out all the other noise. And here's a perfect example of what a view title looks like in practice. This isn't just some random collection of objects. It's a specific, measurable, and logical package of work. By building out these views, you're actually creating the entire structure for your bill of quantities before you even measure a single thing. It's brilliant.
And this intelligence goes even deeper, especially when it comes to detailed calculations. Let's talk about a wall's area for a second. The gross area is just the simple length times height. But that's not what you're actually building or pricing, right? You need the net area with all the doors and windows deducted. The system does all of that for you automatically. It gives you the precise buildable quantities without you ever touching a calculator. So the big question is, how does this amazing data get from the model into your spreadsheet? The answer is a really simple but powerful little thing called a variable. Now, a variable isn't just a number you type into a cell. Think of it more like a live data wire. When you place the volume variable into a cell, you're telling Excel, hey, go find the real-time volume of this specific object in the model and keep it updated for me. And this, right here, is where the magic really happens. Because these variables act just like normal numbers in Excel, you can use them in all your standard formulas. So a formula like equals volume times rate is now totally dynamic. If an engineer makes a slab thicker in the model, the volume variable updates, and bam, your cost calculation updates instantly. You didn't have to do a thing. All right, this all brings us to the final and most powerful piece of the puzzle in Section 5. Automating your final quantities. This is where we take all these live linked elements, all this structured data, and use it to build a truly intelligent bill of quantities.
Now look, the absolute key to any good automation is standardization. So instead of starting with a blank spreadsheet every time, you start with smart templates. These templates are built around major industry standards that you already use, like CSI MasterFormat in the States or NRM2 in the UK. They already have the structure and the logic built right in.
So how does the template know that a certain wall needs a specific cost code? Well, it's not some crazy black box magic. It's actually simple lookup logic, just like an index/match or a VLOOKUP function in Excel. The system just reads the element's description from the model, say concrete slab, looks it up in a table, and automatically assigns the right line item and cost code from your template. This one step can save hundreds of hours of manual coding.
And just like that, the journey is complete. You've gone from the total chaos of trying to manually track revisions and remeasure everything by hand to a structured, intelligent workflow that gives you a self-updating and just a far more accurate bill of quantities. You've literally connected the design directly to the cost.
So I'll leave you with one final thought. We all know that buildings are dynamic. They're constantly changing and evolving throughout the entire design and construction process. So the real question we have to ask ourselves is, why are we still measuring them with static tools? Isn't it time our budgets became just as dynamic as the buildings they're supposed to represent?